Hi there, today I'm looking at my wife's Citroen C3 Picasso. The engine light's on, so I'm going to plug in one of my old scan tools that I keep in this car and see what the fault is. So there's the engine light up there on the dash. I'm using this old Foxwell. I'm going to start with OBD. Since the engine light's on, I'm expecting it to be in the OBD. Occasionally I get a fault in there that's not in the manufacturer. But we'll see what it says. I haven't got a clue how this is going to go. 2 fault codes. Yeah, it had no power actually when I took it out, so I'm just going to press that one again. Enter. And I haven't used this for a while, so read codes. Stored codes. So I might have to tell it it's a Citroen there. I've got to press any key to continue. Let's see if it's got Citroen. Oh, it doesn't. No Citroen, so maybe a Peugeot would be the same if that's on the list. Let's see. No, doesn't have that either. So in this case, I'm just going to go into other. Manifold absolute pressure, barometric pressure correlation. So there we go. We've got the 0069 and the 1351. They shouldn't be too hard to figure out what's going on. I'm going to bring up the boost pressure and see what it says it is just now. So if we go back again, live data. Got my wife waiting outside of the car. I thought she was coming to say something. We could get the complete list, but we don't really need it. There's the map, see that? 240 kPa, which is wrong. See that one right there? That I've got in white. That's the map, or the boost. Manifold absolute pressure, don't know if you can see that. So in this area it should be 100 kPa, roughly, for 1 bar, right? That's 1 bar, and we're usually around the 1 bar. So something's gone wrong with that sensor, typical. I was going to send this for the MOT. Gonna do the MOT this week. I'm all bunged up with a cold. Ears are bunged up and stuff, but at least we've got a direction, we know what the fault is. What I could do is go into the Citroen side of the scan tool and see what that tells us is going on, but we already know what direction we want to check. I wouldn't change a part based on a fault code, but what I can do is go to the sensor and check that it's working. So the fault code is the boost sensor. In this case it says it's the map sensor. Manifold absolute pressure, or the boost pressure sensor for the turbo. So we've just got to figure out why it doesn't like it. It looks like whether the engine's running or the car's just got the ignition on and the engine off, it stays the same. It's whatever it was, 200 and whatever kPa, like 2.5 bar roughly, and it should be at 1 bar with the engine off and the ignition on. And when you start it, it doesn't really change much until you start to boost the car, until you give it some revs. So could be a short circuit in the sensor itself, but we'll check it and figure out why. A lot of the time I find it's not a wire. A lot of the time I find it is actually the sensor itself that's faulty, but it's always worth checking. When you get something like this, it's always worth checking around. It's going to be on an intake pipe. So it's not going to be this one. I wouldn't think that's going to be the mass airflow, because it kind of looks like a mass airflow. It's the whole thing there. So if we look over here, we've got this one. It's 2 wires, so that'll be a temperature sensor. An intake temperature sensor. That's another part of the intake. This one's got 3 wires, so that's the one that I'm going to look for right there. It's got to have 3 wires to be a sensor in this case. It'll have 5 volts to supply the sensor. The signal will change depending on the value of the pressure, and that'll change the voltage. If it doesn't change the voltage, it'll change the frequency if it's working that way. But the other one will be a ground, so as long as we've got 5 volts and a ground, I'll do some checks on that. But for now, I'll have to stop. I just got, my wife's just got a hot dog and some fries, so I'm gonna go and eat that, and then I'll come back and check the sensor. My phone was playing up because when I'm working in the rain, the phone doesn't work, and this stuff doesn't work too well. It's not ideal if you're mobile and you have to work in the rain. The battery lead, the black lead, is on the battery negative. The ignition's on the car, although it's down a little bit in power. It's probably only 12 volts in there. This lead, to help me get in a little bit further, I've taken the cover off. There, we're just going to go through these wires. That's connected into the multimeter onto the other side of it. So we've got the rain's getting a bit harder now. First wire is 4.9 volts. As a guess, I'm going to say that'll be the 5 volt supply, because these only work on 5 volts. We don't need a 12 volt system. The center wire is millivolts. See the millivolts there in the rain. So what we can do, 2 things. You could either shake a lead like that and see if that fluctuates, and it's not. So we know it is actually reading 0 volts. And take this lead. See if that was going to change when I shook the wires. It would just be that it's not connected like that. It's really not easy for you to see with this rain, like that. See, it changes it. So if we go to the power, although it's the black lead, the negative lead, I've put it on the power, on the positive on the battery. Now we're at 12. So now we know the difference between this lead of the multimeter and this lead of the multimeter. There's a difference of 12 volts. So that's going to be the ground. I'm happy to say that's the ground wire. I'll put that back on to the negative and go into the last one over here. This little purple wire. I can get into there. Sometimes it's making sure you're in properly, so you get a good reading. There we go, 4.5. It's a little bit lower than the other side, so I'd say that's the signal. So we can get a test light, check the wires, even confirm it against the scan tool and see what happens. So I got this test light connected to the battery negative. If I touch the positive, it lights up. Can you see that? So if I go to this one, that's only a 5 volt, remember? We're going to touch that. I gotta make sure that I'm connected properly though, here. Then come in, the 5 volt supply. And now it's very, very dimly lighting that up. It's only 5 volts, you see. But if I went to the other one that had 5 volts and did the same thing, right, gotta make sure I'm in the hole, in the wire. That doesn't light this up, not even dimly, so we know that's the signal. But if I was to touch that on there, like I am, I'll leave it like that. If I get the scan tool set up again, that should have pulled the voltage down, which means the reading will change. When I pull this down with this connected to ground, when I touch a ground, it's going to pull this wire down. So I'm on the signal. That is 3.9 volts now. If I touch this, it's basically a jumper wire. Just pulled it down to ground. Millivolts again. Let it go and it comes back up again. So we know that we can change that, but the point is, if I unplug this and we've got volts on that wire, we know the wire's okay all the way back to there. Let's just do that. Unplugged it, it's 5 volts, right? Do the same thing. Touch that again. 5 volts has gone down. So I know that wire, I've let go of the wire. 5 volts. And then when I touch it, so that's the signal. this wire comes from the engine ECU, which is down there. So we know all the wires are okay all the way to this. The only thing that it leaves, we've got power, we've got ground, they're both good. If I wanted to, I could go into the ground with the test light and just show you that it can actually light up this. So I'm on the, these are the wrong way around now. When I touch a ground, this lights up. So if I could touch the center one, I have to move this lead over here into the center one. See if I can get that. Might have to do it with both hands. I'll try and do it this way. See, that I get that into there. I don't want to stuff something large that's going to open that up. And this test light, I just dropped it down there. I can get that back up. Check it still works, and it does. So if I touch that, we light up. So we got this to light properly on the ground. With that connected to positive. When that was connected, when the clamp was connected to the negative side, we got it to light dimly on the 5-volt supply, because it's only 5 volts and not running on a 12-volt circuit there. It's only 5, so it lit this dimly. And the other one doesn't like this at all, but it changes the volts. And we know with it disconnected that that power comes from the engine ECU. We're done. It needs a sensor. So I can get the part number off that sensor and get one ordered. You could probably also see a change on the scan tool. If I was to try and short that out, you might see a change on the scan tool with the boost pressure. Right? You should see a bit of a change on there. With that shorted to ground. So I'm back on this Foxwell. I've got the sensor disconnected. If we look at the very bottom one here, 988 millibar, so roughly 1 bar. I'm front probed with a small needle, so it's not going to be damaging anything. I'm going to touch this. It's just touching that. I'm not splaying the contacts open though. It's a small needle. This is connected to the engine block right there, or to the engine mount on the engine block. So that what I'm saying is we're giving it a ground, pulling that down a bit. That 988, has it changed? It's changed a little bit. It's gone up to 1329. So it's changed. By pulling that voltage down, we've changed the pressure on that sensor. So before we had a correlation fault code, so one of them would have been that one, atmospheric pressure compared to the turbo pressure. So we can change it that way by pulling it down. In the same way we could change it by, if we connected this to a battery positive, we'd pull it up, but it's already at 5 volts anyway, so we're not really going to achieve anything doing that. So using test light for a sensor simulator, understanding the wiring, how it works, we knew which wire was which without a wiring diagram. We knew how to test it. We knew that the wire was okay from here to the engine ECU because we had volts on there when I disconnected it. And we know it's what they call a pull down system. That's all explained through Scanner Dana, and using this we can confirm that we've got a change there when we connected the test light. So if you don't have a sensor simulator, just use a test light. And the last thing I could do, I suppose, is take this off here. See, it's no good for your tools working in the rain for people. But we plug that back on. I think it was shorted. Let's see what it says now. Yeah, we got a bit higher there. You see that? 2.34. So the only way I can get this to change the reading on the scan tool is with that plug, the plug on the sensor disconnected. Once it's connected, the scan tool was staying the same. So we just disconnected it and I could see a difference, but I think that's because the sensor's shorted internally and keeping the voltage higher or something like that. It's just, I couldn't get it to do the same test, back probing it and touching it. Sometimes it works that way. Everything connected as it is in the car, and you back probe the signal wire and touch something to it on a test light, and it pulls the voltage down, and it changes the information on the live data on the scan tool. In this case, it wasn't doing it, but I still know that's what the problem is. I could have got a Medivac and and disconnected it, put that on, connected the vacuum or the pressure on the Medivac, and seen how it changed. But it wouldn't change in this case because it's faulty. But I don't need to go that far. Just using a test light and understanding the circuit diagram, how they work, it was enough. We know that Y is okay to the ECU. We're seeing a change on the scan tool, and we know the other wires are okay also to that sensor. It can only be a faulty sensor that's internally shorted. So hopefully it's helpful to somebody. Doesn't have to be this kind of car. Doesn't even have to be that boost pressure sensor. It could be any 3-wire sensor. Check it in a similar way using a test light instead of a sensor simulator. You'll see this is one of the problems with working out in the rain. It's not good for your tools. If you've got a lot of money into oscilloscopes and stuff like that, you get rained off too many times to be using that kind of stuff. Anyway, thanks for watching.